It's not just the water that's moving along the surface of our oceans, though. We'll see that deep water that's along the seafloor is going to circulate differently, and that overall the surface and the deep water is circulating in one giant pattern. But before we get into deep water, we need to talk about something that's called upwelling. And when we have wind that's moving along the coast, the wind is not only moving air away from the coast, it's also going to move the surface water away from the coast as well. So when we start moving water away from the coast, water's going to have to come back and replace it. So for this to happen, we actually have vertical movement. Deep water is going to upwell, or it's going to move upwards towards the surface along the coast because we're moving all of that coastal water farther offshore. Coastal upwelling is really unique though because we usually only find it along the west coast of continents. We almost never find it along the east coast where we live. And this is all due to differences in plate tectonics. Along our west coast, where we generally have subduction, we have really deep seafloors. So we're going to allow upwelling to happen. We'll learn later on in this chapter that the east coast doesn't have really deep oceans. Instead, it's fairly shallow along the coast, and because it's shallow, we can't have upwelling. So we generally only find upwelling along the west coast, or the tectonically active region of a continent. And again, it's the winds that are moving water away in combination with the Coriolis effect, where it's causing those movements to curve as they move. That's going to cause all of the water deep underneath our oceans to upwell or move towards the surface. Our deep ocean circulation is mostly going to depend on the temperature, salinity, and the density of the water. So remember from our last chapter that temperature is going to explain whether it's cold or warm water. Salinity tells us exactly how much dissolved salt is inside of the water. And density is how tightly packed are the molecules within the water. So we see that with cold water, it's denser. And because it's denser, it's going to sink towards the bottom of our oceans. We see that high salinity water also has high density. And this is because with high salinity, we have more molecules inside of that water because we're dissolving the salts inside of the water. So increased salinity causes increased density. So when we look at the water that's deep in our oceans along the seafloor, we see that it's always very cold water, it's very high salinity, and it's also very dense due to the fact that it's cold and it has a high salinity to it. When we look at our planet, we're going to see something that's called thermohaline circulation. And here the word thermohaline. Thermo means temperature, haline means salinity. So all of this thermohaline circulation means circulation based on temperature and salinity. This thermohaline circulation is going to move water across our entire planet, both warm surface water and that really cold, dense, deep water. And in order to start changing the density of our water, again, we just have to change the temperature or the salinity. To increase the density, we either want to decrease the temperature, making it colder, or we want to increase the salinity, packing more molecules into the same amount of space. When we're looking at this thermohaline circulation, we see that most of our cold, deep ocean currents start off in our high latitudes around the poles, and our warm surface currents start off in our warm areas around the equator. And overall, the combination of our warm surface and our cold, dense, deep water creates a conveyor belt that goes through our Atlantic, Indian, and Pacific Oceans and then circles back again. So think about the conveyor belt the next time you go grocery shopping. You're going to put all of your groceries on the surface of the belt, but the part that we can't see is the subsurface, what's underneath and spinning through. Our oceans move in the same way. We have simultaneous movement of warm surface water at the top and deep, dense water moving along the seafloor.